Welcome to a tutorial video on C++. In this video I'm going to talk about looping. Looping in C++ works similar to conditional statements. These were reviewed in the previous video where we talked about the result of a conditional statement, if true, does something. Looping works on a similar idea, that is, it continues to do something while the condition remains true. So we needed to sort of understand how conditional statements worked before we can move into looping, since the ideas build on each other. So let's look at this. When we're looking at loops, there are two different types of keywords that are used in C++. For and while. These are the two different types of looping structures. There is the for loop and the while loop. And each of them work in slightly different ways, are optimized for slightly different patterns. Both can be used for either one, but they're slightly different use cases, and I'm going to talk through these now. Let's look at a for loop. So down here on line 11 through 13, we see the use of the for keyword. It works similar to conditional statements, but has some additional parts. When we're looking at a for loop, we care about three things to start. Notice, like a conditional statement, it has an open and closed parentheses, and these are the parts of the for loop. The first thing we care about is the initial value. In this case, it's set integer I is equal to 0. So this is our initial statement, our initial value. Next, we have the conditional. The for loop will continue to run as long as the condition remains true. So we set an initial value to 0. As long as 0 is less than 10, this loop will continue to run over and over and over and over and over and over and over again. So we have our initial value, we have our conditional, and then we have what should happen at the end of each loop. In this case, we're using the incrementer. The incrementer operator adds 1, integer 1, to the value. So we're saying each time this thing goes through, increase I, the value I, by 1, starting at 0, and we're going to keep looping, testing at the beginning of each loop if the condition is still true. Now, the last thing I haven't talked about yet is what happens inside the loop. In this case, line 12, it is looking at the variable number array. Number array is an array of integers. In this case, we know that because the type is int. It doesn't have any values, though. We're just saying, hey, this is a variable. Its type is integers. It has space for 10 things. So we're starting at 0 and going up to 9. We know we're going up to 9 because if we hit 10, this condition would no longer be true. So let's walk through this here. We run this initial statement, set I to 0. Then we check, is I less than 10? It is. 0 is less than 10. Then we jump down here and check this. So, okay, using the index I, 0, set the value of its same index to be its value. So the first index 0 is set to the value 0. The next index 1 is set to the value 1, etc. The last thing we're doing here is incrementing I by 1. So remember, the very first loop, the first two things are done, then it does the instructions, and then it jumps back to this last part. So it sets initial value, checks the conditional, runs the instructions, does this last thing, resets the condition. So the very first loop, it's doing these two things, then the instructions, then this thing. The next loop, it's doing this, then checking this, then doing this. So it checks the condition, runs the instructions, increments. Checks the condition, runs the instructions, increment, and keeps going until the condition is no longer true. In this case, it would no longer be true when I is no longer less than 10. So one use case of a for loop that's very common is in fixed loop structures, when we know how many times we want to move through something. And this, in fact, is very common, is to use a for loop to move through an array, because we can know either the value of the array or we can dynamically calculate it using some additional math. So we want to know how big is this array or how big is this data structure, and then we can move through each item in the data structure until we run out of them. This is a very, very common use pattern for a for loop. So we see here in our examples of line 11 through 13, where assigning its index to be its value of number array, the index 0 is equal to 0, the index 1 is equal to 1, until we run through all of this, with 10 total things starting at 0 and ending at 9. So that is a for loop. Again, we care about 4 different things: its initial value, its condition, right here, whatever should be done at the end of each loop, and what instructions are inside of that. And these look very familiar to conditional statements, which look similar to functions, and they all operate on a similar grammatical construct here. We have a keyword, we have something it's doing with an opening and closing parentheses, and then its reaction to or something it should do if things are true within opening and closing brackets. In the case of conditional statements, if the expression or values are true, we run what's inside the open and closing curly brackets, and in the case of a for loop, if its condition is true, we keep running what's inside of that until the condition is no longer true. So we've covered for loops. The other type of loop is a while loop. We see a while loop right here in 17 through 22. A while loop looks similar grammatically in structure to a for loop, but it's a little simpler to write. Instead of 3 different things, an initial statement, a condition, and what should be run at the end, we just care about the condition. And this is explained as, while this condition is true, keep looping, keep looping, keep looping, keep looping until the condition is no longer true. In this case, we've introduced a new variable right here on line 15. The new variable is named counter, its type is integer, its value is 0. We see on line 17 that while counter with its initial value of 0 is less than 10, while this is true, keep running this code, keep running this code, keep running this code, keep running this code. And so we need some way to change that value within this. We're returning this idea right here in line 21 of the incrementer. So we're incrementing the integer value counter by 1 each time this runs. And so you noticed in both the for loop and the while loop, we have some internal structure to stop us from doing this infinitely. And that is a problem you can run into sometimes when designing loops, is this infinite loop structure. If loops just run in an infinite way, they never stop, and therefore your code never stops. And so there needs to be some type of structure built into it to stop that code, and so you can use the conditions and code within it to build those structures. So let's return to this and think through what this is doing. We're starting with initial value 0 for counter. Counter is initially less than 10, so we're running what's inside the opening and closing curly brackets. In this case, we're using a printf function we've been using throughout all of these examples, and we're printing the value of counter. The initial value of counter is 0, and then we're running each time while the condition of counter is less than 10. Counter at the end of this loop is being incremented by 1 each time. Let's run this. So we see that the while loop ran the entry 0 through 9, running each time and generating a new value, running through these. So we looked at 2 different types of looping structures within C++, the for loop and the while loop. The for loop usually, but not always, are used in fixed cycles or with a known number. So when we saw this appear, we were running 10 because 10 matched the number of entries in number array. It was its length. So using a fixed number, we ran in a fixed number of loops. We established an initial number, I equals 0, its condition, and then what should happen at the end of each loop. In this case, we're incrementing I. Then we assigned its index to be its same number. So number array 0 is equal to 0, 1 is equal to 1, up to 9, because we're looking at 10 entries total, starting with 0. And we ran through this. And I talked how this is a very common use case for the for loop structure, is moving through some type of data. Very common with arrays to either move through the number of arrays or move through some subset of the array. Very, very common usage pattern. Then I talked about the while loop. The while loop is a somewhat simplified version of the same ideas the for loop uses. It uses just a single condition. you'd have to set up any initial values outside of it, and I did that up here at line 15. So using a while loop, we have to set up any initial values or anything that's going to compare outside of it. With a for loop, we can use those inside of it. There's sort of those differences right there. So looking at this, and this just checks the conditional and keeps running as long as the conditional is true. And I talked about the problems of infinite loops. That is, if your loop is doing infinite things and there's no other way to stop it, your program will never stop and you'll have to force quit it somehow. So we talked about those different ways. We see the for loop just runs on the expression. The while loop just runs on expression. The for loop runs on three different things: what happens at the first, what its conditional is, and what should happen at the end. And I talked about the problems of infinite loops. Thanks for watching.